We are going to work through some review problems, including some review of some of the exponent rules and then division by a monomial. So first of all, we've seen these exponent rules, all with the exception of the last one. The last one's going to be addition. So we're going to start by reviewing over these exponent rules by just reminding you that if you multiply with the same base, what you do is you're going to add the exponents. So it's going to be m plus n. If you're dividing with the same base, x being the base of the problem for our terms here, then you're going to subtract the exponents. Numerator minus the denominator exponents. Now, anything to the 0 power except for 0 itself is equal to 1. We talked about the fact that if you eliminate all factors, what you're left with always is 1. It reduces down to 1. And then if you've got something outside the parentheses that you have a couple different variables on the inside, bring it in and multiply by the exponents. So this is where you multiply, where you bring that c in and multiply it by the a, so you got a times c, and then for the y, you're gonna have a b times c for that. And then this last one, this is the new one. So these other ones we review. This new one here, what it tells us is that if you've got a -1 exponent, that means the inverse exponent, the inverse of a term is its reciprocal. So this is going to be 1 over x to the first. Okay, so you're gonna reciprocate it. Now let's do it with a different variable. Let's say that I've got a to the opposite of m power. That means you're going to have 1 over a to the m power. So whatever that one is, you bring it down to the reciprocal place in the denominator. Or what if you have instead, you have 1 over a to the opposite of m power. Then if you have this situation, then what it means is you're going to bring it up on the top. So you're going to make it a to the m power over 1, or you go ahead and just make it a to the m power. So because over 1 is just that number. So that rule, when it comes to the new one, the new rule that we're going to use means it's going to be a reciprocal when you have a negative exponent. Okay, so we'll be using that in different situations. Now let's review over this division by a monomial. When you have a polynomial divided by a monomial, you're going to separate every term in the numerator over the denominator. That's the general technique to use for doing this. So for this first one, you're going to set it up as 27 x to the 7th y to the 9th over 9x to the 4th y. Now I'm going to think of this as y to the 1st, so I'm going to go ahead and list it that way, minus 72x to the 5th y to the 1st. I'm going to go ahead and list it with the exponent over 9x to the 4th y to the 1st. Now I'm going to do each part of it. Now remember with the exponents we're going to subtract because you have a numerator and denominator with exponents, but with the numbers you do the regular division. 27 over 9, don't subtract them. Remember this is 27 over 9. That's the same thing as equal to 3 over 1. It's just 3. So you can go ahead and reduce it like you always have with fractions. With the numbers, it's the exponents that you're going to subtract. So this is going to be 27 over 9 is equal to a 3, x to the 7 minus 4, and y to the 9 minus 1. And that's minus 72 over 9. 72 over 9 is equal to 8, x to the 5 minus 4, and y to the 1 minus 1. So this is going to be 3x to the 7 minus 4 is 3rd power. 9 minus 1 is equal to the 8th power. Minus 8x to the 5 minus 4 power is 1st power. And then 1 minus 1 is the 0 power. Well, remember, 0 power is equal to 1. So what we end up with when we simplify it, here's our final answer. 3x to the 3rd, y to the 8th. Minus 8x, because x to the 1st is just an we just rewrite it as an x, and then y to the 0 is equal to 1. So that's how you simplify. Put each term over that denominator. Let's go ahead and do it with this one here. So we do the same process, -10 m to the 6th, m to the 11th, over 5m to the 4th, plus 35 m to the 7th, over 5m to the 4th, plus 120 m to the 4th, and squared all over 5m to the 4th. So each of the numerator terms gets set over that denominator when it's a monomial, a single term in the denominator. Now let's simplify each of them. Now I'm going to do this a little quicker, okay? Just remembering our rules. -10 over 5 is equal to -2. We divide those two, don't subtract them, divide them because they're numbers. The coefficients get divided. Okay, and then m to the 6th over m to the 4th, you do 6 minus 4 and you get m squared. Okay, 6 minus 4 gives me that 2. And then there's nothing to reduce with the ends, so it's just an n to the 11th. Plus 35 over 5 is equal to 7. When you reduce that, 35 divided by 5, then 7 minus 4. These are exponents on variables, so we're going to subtract them. You'll get m to the 3rd. And then lastly, 120 divided by 5. You're going to divide the numbers first of all. And what you get from that is you're going to get 24. And then m to the 4th, 4 minus 4 is m to the 0 power. M to the 0 is equal to 1. So all of these, notice m to the 4th over m to the 4th, that's equal to 1. So we don't have to write it. And then times n to the 2nd, because I still have that one that I didn't reduce with anything. So we just went ahead and talked through some of those steps. So our review is, we first of all reviewed over our rules for exponents to remind you of several of them and introduce a new one, the reciprocal rule. Let me just write down reciprocal here so that you remember that that's what this is referring to when you have a negative exponent. Okay, and then down here, we reviewed when you divide a polynomial by a monomial, you put every term over the denominator, single monomial, simplify each of those terms to get your final answer.